Welcome to the channel. This is the first video we're going to talk about on a series for pre-calculus review for a calculus class. If you haven't taken math in a bit but have gone through high school math, what we're going to cover in these series, and especially this video, then this is the video for you. A little bit of reminder. We're not going to go very in depth. We're going to cover 5 topics here. We're going to go through definition of a function, domain, range, that sort of thing, some basic ideas, table, graphs, equations, words, the relationship between all these things, going back and forth. Linear functions, for sure, the y equals mx plus b, that basic one, and a little bit more in depth about families of them. Increasing versus decreasing functions, and finally proportionality, or rates, that sort of thing. All this stuff you should have covered in your pre-calculus algebra courses, geometry maybe, and that's what this playlist is, the first video. So let's get started. So let's look at the first item in our pre-calculus review for this video, and it is the definition of a function, which simply means that each input has one unique output. So take a look at this data, one unique output, and keep in mind that the top row, date, this is some random data that I made up for snowfall for January. Units do matter, so the snowfall is in inches, but you should be okay with that part. But this is the independent variable, and down here we have the dependent variable. So snowfall depends on the date, which makes sense, of course. So this is a table. It's a definitional function. Each input has only one unique output. We want to also talk about the domain and range of a function. So the domain is simply all the allowed values of the independent variable. So the allowed values of x is what we think about it usually. And the range is just the allowed values of the other thing, snowfall, or the y value. Might be a little easier to think of it that way. So a quick example we'll look at here, and let's look at a very well-known function, a parabola, y equals x squared. So that's what we have on this axis here. It's just a basic parabola, and it does touch at the origin, so we'll make sure that does that. And we can write the domain in a certain notation. All allowed values of x, nothing is excluded, so we say that x can be negative infinity to infinity. That's the domain of this function, y equals x squared. And the range, y, is also, sorry, it's not also, it is bracket 0 to infinity. Because it can be 0, that's what this little bracket means, including this value 0, but infinity always has a parentheses, okay? Domain is x, the range is y. And we talk about f of x sometimes, but this is simply, we call that y. So don't get confused by that. The last thing I want to talk about is set notation. You'll sometimes see this same thing here. This can also be written as negative infinity less than x, and x less than infinity. Notice this is not equals to, like it will be here, 0 less than or equal to y to infinity. These things mean the same thing. We usually use this. This is called interval notation. This is set notation, kind of. And that's it for this, is the basic stuff. Remember, please, you have to make sure you understand this and spend the time you need to go through this and make sure you have this basic stuff down. Let's move on to the second section now. Section 2, tables, graphs, equations, words. I really just want to say that we can use all 4 of these things to describe math. We used a table the first time. We used a graph and an equation before, so this is the equation, y equals x squared. We just graphed it. It looks something like that, right? We can also create a table, x versus y. You know, when x is 0, you plug it into the equation. So y is 0. When x is 1, y is 1. When x is 2, y is 4, and so on and so forth. And then you can say it in words and say, well, y is equal to the square of x, something like that. Should have a lot of practice with that by now. And I just want to mention it, that you are expected to know all of these things and how they are related, and to make equations and graphs from words. That's what they're going to test you on, right? They're all going to be word problems for the most part, so make sure you understand that. So let's say I have some linear function, I don't know, y equals 26 minus 3x, okay? Notice we could use t instead of x. I don't really care. It doesn't matter. But there's the equation. Let's graph this thing now. And remember that the constant value here will have a y-intercept. So that is a point on the line. And it has a slope of minus 3. So we go down 3 and over 1. So we would be x equals 1, 2. Y over here. This is the point 0, 26. This is the point right here. It would be 1, comma, 23. And you only need 2 points to do a line, so you can simply connect the dots. Hopefully that makes it nice for me. That's good. It goes on forever. And that is the equation of our line. That's what it looks like, and all of that. So you need to know what the general form is of a line, and we say y equals mx plus b, something you should know extremely well by now, especially if you're even watching this video. But there it is. There's a linear function. Y depends on x. Each x value has one unique y value. Remember that it's really important to know what that is as well as b. So let's talk about those for a minute. M is called the slope of the line. And there's all these interpretations. We can say slope is rise over run, or we use the delta notation, which becomes very important in calculus, and if you take physics also, delta y over delta x, okay? Which simply means a change in y, y2 minus y1, that's just a change, a difference, divided by x2 minus x1, a change in x. That's what these things mean. All of them mean the same thing. And notice that as m gets larger, we will increase our graph. So here is some m value. I'm not sure what it is. But if I go like that, for the same b, that means it's the y-intercept. Remember that b is the y-intercept right here. Well, the m here is much greater than the m down here in green. Okay? Let's call it some variables, get you guys used to that. But we're saying that m1 is greater than m2 because we can see that the line is steeper. Hopefully that is just a basic review and you're comfortable with that idea. Finally, we have b as the y-intercept, or where does this thing hit the y-axis when x is 0? Well, whatever b says. Whatever that number b is, notice that b here is 26. Well, the point 0, 26 is the y-intercept. Keep it in line with that. We call this a linear family of functions, this kind of general equation here. You don't need to worry about it too much, but just know that, hey, m can take any value, and so can b, and, well, the graph changes accordingly, and it looks a lot different for different values of m and b. And you definitely need to know the equations here for m. I want to talk about one more thing with m, get you used to this notation. We said y2 minus y1 over x2 minus x1, but as I said before, this could be written as f as a function of x, so we'll shove in x2 and x1 in our function. That's what it's saying. So you need to be very comfortable with both of these kind of forms and the notation here, because when you get into that class, they're not going to babysit you at all on the algebra. It's a sort of a weed out class, so you do need to be very comfortable with all of these ideas as well as your kind of basic algebra trig, but that's what this review is, and we'll get through that through this playlist. Okay. Now let's take a look at increasing versus decreasing functions. This is pretty simple here. We want to use the same interval notation as before. So first, this is an increasing function, and we just kind of say, well, if it climbs as we go left to right, and if it falls like this, we would say that it's a decreasing function, looking in left to right, so as x gets larger, essentially, if we were to plot this. And that's pretty much it. It's just need to know if it's increasing or decreasing. It's very important in Calculus 1 when you deal with derivatives and all that sort of thing. You really want to, we want to be a little more exact, usually, if we have half a parabola here. we say that it's increasing, well, it's climbing 0 to infinity. That's when it's increasing. And it's decreasing negative infinity to 0. Notice the parentheses on the zeros because it's not increasing or decreasing at 0. It's a local minimum. So that means that it is neither increasing or decreasing. And we use the parentheses for that interval notation. And then the last thing we're going to look at in this video is proportionality. And we can write down, let's say, an equation, the area of a circle, for example. By the way, your geometry also needs to be very good. Area, surface area, cylinders, spheres. We're going to cover all that. But A is proportional to the square of R. Those would be the words that describe this equation. Guess what the proportionality constant is? Pi. That's just saying that some constant out front. For a linear function, we can say y equals kx if y is proportional to x. This is proportional. And k, again, is that proportionality constant. We call this thing. So if it's positive, then as x increases, y will also increase in a linear fashion. Notice that this is the same essentially is y equals mx plus b. We're just saying now that b is 0 and substituting m for k. You want to get very comfortable with that idea. Remind yourself, hey, I don't care about the letters r. It means the same thing. This equation here is b equals 0. These are the exact same equation. I don't care what the letter is, right? Because m and k can be any values. So that's what you need to know. That's almost it. We talk about rates a little bit and, well, how much is it changing? Well, k is clearly y over x. That gives you the rate, how much y is changing with respect to x. That's what this thing tells you. The last thing we want to say here is that if it's inversely proportional, I'll use, a different proportionality constant a, but now if it's inversely proportional, well, it's 1 over x. So that if x increases, y is going to get smaller. And you can convince yourself that based on what you know about fractions. And how if the denominator gets bigger, well, the thing on the other side of the equation has to get smaller. That's just the nature of it. And we call that inversely proportional, okay? So that's everything pretty much for functions and change. Again, this is not supposed to be very in-depth. You just a reminder of these basic ideas. There's a lot of resources out there. Particularly, you can go to my website and find reference sheets and worksheets and all that sort of thing. Make sure you're ready for Calculus 1 because it's a tough class. It's a weed-out class, and they make it really hard. It's hard the first time you take it. So make sure you're prepared with all the trig, algebra, and everything you need to know. That is the purpose of this playlist. And thank you so much. Check out the next video. Study hard.